Hey y'all, won an auction on eBay the other day, and it came in today. Let's take a look here. They did a nice job at packaging it. Well, they sent me the wrong power cord. They did have it powered up in the images in the auction, so it would imply that they have the right power cord somewhere. Okay, you might already know what this is by the title. This is a HP 467A power amplifier. Looks to be in pretty nice condition. All the jacks and switches are in good shape. Usual wear and tear for something this age. Now this one has the BNC input and output on the back, which is nice because not all of them that I was looking at had that. Let's see what fuse is in it. I've been bit by this a few times. So the voltage selector is set to 115, which is good. It needs a 0.8 amp fuse. And it looks like we have an 8/10 of an amp fuse. It says 8/10. I might have to double check that. I'm not familiar with that naming convention. I'll have to pull the manual and see what it says. But let's open it up. So my intention for this video was to open this thing up and inspect it before I applied power to it. It still has all the calibration seals over the stickers, and granted it hasn't been calibrated since 1992, but considering that the seller didn't send me the correct power cord, I'm not going to open it up at this time. I actually opened a case with eBay. They showed in the pictures that the thing was powered up, so they must have had one, but they just happened to send the wrong one. I saw that they had a few of these for sale, so I have a bad feeling they probably only had one cord and then took a picture of it powered up, thinking that they could just send a regular computer power cord. So hopefully they either find the cord and send it to me, or just refund me about $50, since that's what it costs to buy one of these cords. And sorry about that, the dogs are playing in the background. So the fuse, that's 8/10, that's 8/10 of an amp, duh, should have thought that. Just used to seeing them in decimal form. So anyways, this thing acts as either an amplifier or a power supply. You can select the gain on the amplifier here, and your inputs over here. This one also has the BNC option on the back, which is nice. Or you can use it as a power supply, and here's your voltages here, up to plus or minus 20 volts. No, it's not. It's not like a dual rail power supply. So you go from -20 to +20 just by turning this knob here. So I'm going to set it back to 1. I'm going to go ahead and flip it on. I put it on the dim bulb tester just to be safe. I really wanted to look inside. I assumed some of the caps are leaking and things, but let's see what happens. Okay, so just little bit of flash from the dim bulb tester, but no shorts or anything like that. And yeah, I'm not liking that. I am not seeing any change in output with any action on the knob, or I switched to amplifier, nothing. That's not good. I'm going to take it off the dim bulb tester and see what happens. I took it off the dim bulb tester just to see if that's any different, and it's not looking good. This thing seems to have issues. I'm going to have to write back to the seller and tell them I need a refund. Alright, well, I contacted the seller on eBay, and man, that was a big pain. they basically sent me a return label and said send it back, and eBay's return system doesn't allow you to communicate with them after that. So I had to send them a message outside of the return system saying, hey, you know, if you give me a pretty hefty partial refund on this, I'll buy the $50 power cord and take my chances repairing it myself and not send it back. And they agreed to that, but fortunately the way eBay works is I had to cancel the return request before they could issue a partial refund. And once you cancel the return request, that's it. You can't get help from eBay at all. So this person could have just went on their way and never sent me a partial refund, which really sucks. But luckily they were really cool and understanding, and they sent me the partial refund here. So I got this for a little over $100 now. You know, at least it's in nice physical condition. I'm sure I can fix whatever's inside it that's broken, and I'm happy to have it. So we'll see what we can do. And I'm really not one that's going to want to spend $50 on a power cord anyways. Alright, so I'm going to go ahead and start taking some of the covers off of this thing and see what we're dealing with here. Of course, the stickers are being a pain. Alright, what do we got here? Is this a Phillips head? Alright. That's actually a posi drive screw. Let's see. A couple nice Dale chassis mount resistors there. Not too much to see here. A couple multi-section can capacitors. There's the outputs. Nice big heat sink. Let's try taking this side panel off and see if we get a better view of that board. And I don't do many repair videos, first of all because I'm not an expert on this stuff, and second of all, man, it's not easy. It's not easy with a camera in front of you trying to work on this type of gear. Let's see here. Get this off. Oh yeah. Well, those Sprague axial caps in the back there, hard to see here. That one was pretty dark, but I think that's mostly just the transistor here heating the plastic around it. But we'll have to disassemble this a bit more and test these. And obviously a lot of these old Spragues, these silver Spragues, I've seen gone bad in a lot of this era HP equipment. Working on an HP 651A oscillator as well, and there was a whole bunch of these guys that were bad. These other Spragues here, these plastic coated ones, I forget what they are, 34D or 41D series, I forget. They seem to actually measure pretty well, even though they don't look very good. Alright, that's as far as I'm gonna take it apart for the moment. I should probably be a little bit more methodical about it, but since I suspect these capacitors, I just pulled this board out. I'm gonna check them. Well, I suspect some of these Sprague caps, so I'm going to go ahead and I lifted one leg on them. These are on the, looks like 15 and 7 volt rails. And let's see what we get here. I have a feeling some of these are going to be shorted or open. Yeah, so that first one's registering as a 92 ohm resistor. Showing 10 microfarads. It's a 100 microfarad capacitor. This other one, that one's actually registering as a capacitor, although it's all over the place. Yeah, that's not normal behavior. 50 microfarad caps. 59, that one looks okay. It's also looking okay. So it looks like it's these 100 microfarad caps that aren't happy. At least this one. The other one might be okay. I'm going to replace all 4 of them anyway. Yeah, that one's definitely bad. I'm going to be using some 47 microfarad caps to replace the 50s. These are rated 50 volts instead of 25. and they're Panasonic FRs. I'm also going to use some Nishikon UPWs, 100 microfarad 35 volts for the 100 microfarad caps. And I am going to be using radial parts because axial parts are expensive and specs on them usually aren't as good. If you look at like the ripple current and different things, they're actually pretty terrible considering, you know, this cap, which costs pennies, probably costs at least $3 in axial, and it's good enough for this. $112. I'm going to write on the board what it was. That way in the future, if I have to replace it again or anything, I know what was originally there. I'm going to use some of this Teflon tubing on one of the leads, since you can see it kind of goes over another one. This board is a double-sided board, so it's giving me a little bit of trouble here. I'm going to resolder this. Bought this tubing on Amazon. It was only a couple bucks. Wish I got more because I've been using it quite a bit. That's not good. These Sharpie paint markers suck. I'm not going to show you the other side, you get the idea. Alright, so on the other end of the board, I lifted these two caps. This is an 80 microfarad 75 volts, and that one is a 375. They actually look okay, but they're probably leaky. I'm going to replace them anyway. So the 80 measures 74, which is pretty good. Let's see what the ESR is. 0.22, that one's actually fine. And then the 300 is measuring 0.37. I might leave that as well. And so down here on the other end of the board, we've got an 80 microfarad 75 volt and a 300 microfarad 15 volt. I'm going to leave this 80 in here. It tested okay, and capacitance in ESR was like 75 and 0.2 ohms. I didn't check it for leakage, but I don't have one to replace it with anyway. And then this guy was also pretty good, but I am going to replace that since I have that value in stock. So I'm going to remove that 300 microfarad capacitor. I noticed some green crusties on this resistor here. I'm going to clean those up and test that resistor as well. Alright, so I realized I forgot to shoot the clip at the beginning of the video where I checked the power rails with the multimeter. They were actually reading 1 volt or less. There's a plus 15 and minus 15 and a plus 7 and minus 7 rail. So I've got the board back in there with the new capacitors on it. We're going to give it a try. I actually already plugged this in and I know the results, so it's not on the dim bulb tester or anything like that. Let's go ahead and flip it on. Alright, and it made a click that it wasn't doing before, so that's a good thing. So let's check this plus 15 volt here. We're at plus 15.9. Let's check the minus 15. Minus 15.2. Okay. And the plus 7. We're at 7.5. And the minus 7. $7.5. Actually have the leads backwards on the negative, but it's okay. They're good. See, once I get a good connection. I actually have some Probe Master leads coming up. I like the sharper tip, but thought they were going to be here today, but I guess not. So that looks good. Let's plug this in to the meter with some banana plugs and see what we get from the power supply. Alright, I've got the 467A plugged into this Fluke 289, and it's on the plus minus 1 volt range, and I'm already seeing good results. That's not showing 28 volts anymore like it was at the beginning of the video, so that's wonderful. And let's see here, this is, there we go, minus 1.09, plus 1.11, perfect. There we are at 2 volts, minus 2, right, minus 4, plus 4, you know, plus 10, minus 10, minus 20, plus 20. Well, pretty close. I'll have to read the manual and see what sort of adjustments there are. Doesn't sound like there's too many from what I've read, but if it goes over a little, that's fine as long as it's symmetrical. There's a 0 setting here, which I think you can change that balance a little, but that's good enough for what I wanted this thing for. I already actually tested the amplifier section on this as well, and what I found is that the switch is dirty because the only setting it works in is variable. It kind of works on the other settings, but they're cutting in and out, so we're going to have to clean that wafer switch in there with some deoxit, and then we'll get it on the scope. So the wafer switch for the range selector is buried in there pretty good. I'm going to spray it off camera because I don't see how I'm going to get that on film, but it's basically right behind it down in here. There's some boards around it and looks like some sort of shield there. So hopefully that clears that up. Now here's something cool I thought I would share. If you look in there, the potentiometer, it's really hard to see. It's made by Fluke, John Fluke Company. That's pretty cool. I've never seen HP use a Fluke part inside their devices before. Alright, so here's the setup. I've got an HP 201C putting out about 2 volts through a 600 ohm terminator at 200 hertz into channel 1 on this 7704's vertical amplifier. That is going out to the input on the back of the 467A. I have a 10 ohm load resistor connected across the front of the 467A on the output, and then the output of the 467A goes into channel 2. Both traces are set to 2 volts per division. So with the 467A switched on, you know, the traces are right on top of each other right now at 1x gain. Let's bump it up to 2. So there we go, they're at 4 volts peak to peak, and then 5, right, 5 divisions, and 10, we're going to get cut off, but it's at 10 divisions. So that's working well. Let's try the variable gain setting. There we are, nice and smooth. That's that Fluke vernier potentiometer there. So I am really happy with this thing. I'll probably get the manual for it, and if they have a performance validation section, maybe run through that. Might need some more tweaks. I might also look at replacing those multi-section cans if they test bad with some adapter caps. And there was a few more of these silver sprays in there on another board. I'm not sure what board that was, but it was really hard to get to, so probably have to give this some more attention. But I'm just really happy that it works after that whole ordeal with eBay. So here's an example of what I wanted this for. I picked up this frequency meter at a Hamfest. It was new old stock, and I want to use it on my portable generator that I hook the house up to when the power goes out, since its frequency varies based on the speed of the engine. Thought it'd be cool to make a panel with analog gauges, but when I plugged this into the wall outlet, which I knew was 60 hertz based on what my meter was telling me, and plus it's, you know, everyone knows the power in America is 60 hertz, it was reading like 62, so I had to figure out how to calibrate it. And what I found is you need to give it 120 volts for it to work. There's a resistor on the back, a wire wound power resistor, and this meter only comes alive when it has 120 volts or so going into it. And what I needed to be able to get 55 hertz and 65 hertz at 120 volts. So when I actually did this already, and I used an Adcom audio power amplifier, but I wanted the HP amplifier because it's a nicer solution. I don't want to risk damaging my audio amplifiers. These HP 467s are much more resilient. So basically I've got the same setup here again. So I've got my HP 3325 outputting, looks like a 1.28 volt signal, which is then going into the 467. I've got the gain pretty much all the way up on this. And then that is going into a 12 volt to 120 volt transformer, just hooked up backwards, so the output of the 467 is going to the 12 volt winding, and that's going over there into my bench meter, so I got about 118 right now. And then from there I have 2 clip leads going over to this frequency meter, so what I can do is I can just modify the frequency here on the 3325B. I'm at 55, 56, 57, and this thing's still a little off, but I can set the frequency on it. And there's other test equipment that wants AC voltages at certain frequencies, and I didn't have the capability of doing that beyond what my signal generators could do with their own internal capabilities. Now, I'll probably need a better transformer for higher frequencies. I'll have to play around with that and see what I can come up with, but this works for now. And for anyone wondering, can you play music through this? The answer is yes. So I've got this Mac Pro back here connected to the Superfon preamp, and then from the Superfon preamp I'm going into the rear input on the HP, and then from that I'm going to my bench speakers, which are a pair of Polk Monitor 5s. Yeah, it puts out about 5 watts. It has I guess a ridiculous damping factor into 8 ohms. It's like 1600. Sounds pretty good. Let's give it a shot. Alright, and that's all I got for today. Take care.